Heat transfer is known as the exchange of thermal energy. In most situations, heat transfers from a high temperature object to a low temperature object. In this video, we will discuss the three main types of heat transfer: conduction, convection, and radiation.
Conduction is the process by which heat energy is transferred through collisions between neighboring molecules. To further explain this concept, let's examine a frying pan on a gas stove. As the flame heats the metal, the molecules that have direct contact with the flame start to vibrate. These molecules then vibrate against neighboring molecules, which in turn vibrate against their neighboring molecules until all the atoms that make up the pan are vibrating. This movement or vibration of the molecules releases heat. At this point in conduction, if you were to touch any part of the pan, you would burn yourself. How well an object conducts heat depends on the bonding within the atomic and molecular structure. Solids are usually the best conductors of heat because their particles are tightly packed, as shown in the figure at the left. Liquids and gases can conduct heat, but in order for conduction to take place effectively, they have to be contained. The reason for this is the particles of a liquid are close together but have no definite shape. Gases also have to be contained for conduction to take place because they have no definite shape and their particles are spread apart, as you can see in the figure to the right. Poor conductors of heat are called insulators. An insulator is designed to reduce the rate of heat penetration. In other words, insulators slow down heat transfer. Some of the most common insulators are wood, rubber, cotton, plastic, and glass.
Convection is the process of heat transfer caused by the movement of fluids. The movement in the fluid carries energy as it flows. It is this movement of liquids that allows for energy to flow through the whole substance. As a fluid is heated, molecules move faster, spread apart, become less dense, and are buoyed upward. Then the fluid that is cooler and more dense sinks towards the bottom where the process is repeated. This process is what we call convection. It is very important to note that convection is a type of heat transfer that can only occur with liquids and gases. Because convection is defined as heat transfer due to the movement of fluids, it is not possible to occur within solid structures. Something that we see on a daily basis that is an example of convection is boiling a pot of water. When we heat up a pot of water, the water at the bottom is quickly heated. As it heats, it becomes less dense and pushes upwards. When this occurs, currents within the fluid appear. The hot water rises, pushing the more dense, cooler water towards the bottom of the pan. Then the process begins again to warm up the cooler water that is now at the bottom. These currents continue to move energy as the water continually heats up and eventually begins to boil completely. We can also see convection in our atmosphere and as part of the weather that is around us. Convection currents in the atmosphere actually make it possible for us to feel wind. Like we can see in this picture, as air is heated by the sun, it rises because it is less dense. As it rises, it pushes the cooler air towards the surface of the earth, where it heats and then rises again. Convection really is all around us, even if we don't realize it. Now that we have a basic idea of what convection is and where we see it, we can now learn that there are two types of convection: natural convection and forced convection. Both of these forms rely on the movement of fluids that carry energy to produce heat. However, as their names imply, one is natural and one is forced. Natural convection has a driving force that occurs due to natural differences in density. Forced convection moves fluids by using fans, pumps, and other devices. Natural convection can be seen in the example we talked about before of a pot of boiling water. The movement of water occurs naturally when heated because the density naturally changes. As for forced convection, we can think of an enhanced fireplace. Some fireplaces have fans installed to help propel more heat into the room you are trying to warm up. Another common method of forced convection is a convection oven. These ovens also have a fan that helps rotate the air inside the oven.
Radiation is the transfer of heat that occurs through electromagnetic waves. Radiation is everywhere. Although we most often think of the sun radiating heat, most everything around us radiates energy. The grass, your car, even we do. There are two factors that determine how much heat something radiates. These are temperature and surface area. The sun has many types of waves that it emits. The ones we can see are between 400 and 750 nanometers. The majority of the waves that the sun emits are ultraviolet and infrared, but it also emits microwaves and radio waves. The Earth radiates much less heat, and most of its radiant waves are infrared. Everything has either a high albedo or a low albedo. Albedo is how reflective something is. Objects of light colors have a high albedo. They reflect heat very well, while objects of darker colors have low albedo. They absorb heat very well. The Sahara Desert has a very high albedo. Its light sand reflects heat, making it hot during the day, but because there are no white clouds reflecting the heat back in, the heat escapes easily, and it can get very cold at night. The rainforest, on the other hand, has a low albedo and absorbs heat very well. That is why it is so warm and tropical. You may have heard people talk about the greenhouse effect. This is when the radiant energy comes into the atmosphere of the Earth but cannot escape because of the clouds surrounding it. White fluffy clouds reflect heat back to the Earth, while dark storm clouds absorb the heat.
We hope you enjoyed this video and learned more about conduction, convection, and radiation.